I don't think it's anything special, is it? It just happens to be branded Tesla and then probably charging 8 times the price.
Yeah, and the bottle's super cool.
Yeah, so here's my 2 Teslas now. And it's going to be awesome when I get this one. Look at this. Look at that thing. Boom.
Do you know when you'll get it?
They're supposed to start production sometime in 2022. So now I have to ride around in this thing in the meantime. But I'm going to get it wrapped. I'll get awesome fat logos all over it, and then put a couple of Concordia computer science things on the doors or something. And then I'm installing one of the turbocharger or the superchargers, not the full one, but like the best one you can get at home, outside of my house, and turning my house into a charging station on their network. So people will come and charge their cars at my house, and I can make money off their buying my electricity. I know, so good. Because we don't have any charging things up here. I'm going to be a destination.
You'll be on Google Maps.
That's right. And then I'll have V come over and sell lemonade out in the yard. And Noah's going to build one of these jujitsu rings or octagons or something like that. I met that guy the other day. We did fight. I won. All right. So we're going to start talking about, what did I say, ROT13 file IO stuff. Before I jump into that, do we have any questions you want me to answer about the exam? Go ahead.
So you're talking about like pointers in C,
Mm-hmm.
and just on the GitHub, there's like a lot of folders. So is there anything specific in there you want us to focus on?
Well, why don't we do a quick example? All right, so, and I'll start with kind of the simple one, and then you can ask if there's questions beyond that. So let's just jump over here. Yeah, so she was asking about kind of pointer review, but specifically on GitHub, we have all these different folders. Is there a specific one? I'm going to say you should probably memorize every line of code in every one of those. I maybe wouldn't do that, but let's look at a quick example. Let me just create a folder in here. Let's call this guy pointer example. And then inside a pointer example, we'll create a main.c. Hello world, yeah, working. There's our starting code thing here. All right, so we want to be very comfortable with the syntax for pointers for multiple reasons. Be able to write it, but also be able to read it, because I'm going to be showing you some code, and you should be able to look at that code and say, this is what it does, this is what the side effect might be, this is what will get returned back to the main program, either through memory or as a return value. So I think when I usually introduce pointers initially, I usually say something like, int a is equal to 5. We'll just define a normal plain Jane integer. And then I'll do something like int star. I'm going to call this guy a address is equal to the address of A. So this variable named A address is of type int pointer. So it holds a memory address of an int. What have I put in there? I put in the address of A, which is an int. Where does that guy live? Similarly, if I do int pointer B and I set this guy equal to A address, and then I say int B, let's call this int B address is equal to the address of B. So we're going to say %d \n %p for a pointer \n %p %p a address b address. Kick it down one more line. Just run this real quick. Oh, B is already A. Wait, no. Star B address is equal to the B is a variable. Do it. B address is a variable capable of holding an int pointer. The int pointer, actually, it's not capable of holding an int pointer. It's capable of holding what's called a void pointer. All right, so let's walk through this first. This is actually an example I don't think I covered before, but we've seen in the code. We've seen void pointers in the code. So this would be a good use of that. All right, this line, easy enough, right? Define an integer, put a 5 in it. Okay, this guy, I want a variable. All of these are variables, every single one of them. Variable, variable, variable. This guy's capable of holding an int. This guy's capable of holding the address of an int, the address of an int, and then the address of something vague. So we can almost think of that like the address of an object or something like that, but this is prior to object-oriented languages. It's not specified to be of a certain type. All right, so what are we putting inside this variable? We're putting in the address of A, where A is a variable that resolves to the value 5. So that is going to be the address where the literal value 5 lives in memory. What's B going to be equal to? It's going to be equal to A address. So these two guys, B and A address, should be the same value. So A address and B should be the same value right there. And this last one is B address is going to be the address of B. So here is the address of B, B address. So now, what is the address of B? Explain this line right here. What is B? What kind of animal is B? What is this guy right here? Okay, well, let's start with the most generic. B is a variable, right? And it holds a value. What kind of value lives in B?
Pointer.
Okay, a pointer, which is the address of A, right? But I'm saying, give me the address of this address. This is, give me the address where the variable B lives. Not the pointer that B holds, but B itself, there is a variable, a place in memory somewhere that's built for holding a memory address, specifically a memory address of an int. Where does that guy live in memory? Well, his address would be right here, which will be a generic void pointer because it's the address of an address. And there's that guy right there. All right, so at the generic level, when we talk about pointers, we should understand that syntax, the back and forth. Because now what if I want to print the value of a address. So here's a address. So if I say a address, print f, a address is equal to %p \n, and then star a address is equal to %d, a decimal value. So this will be a address, and then this will be star a address. The star says, give me the value that lives at this address. This says, give me the value contained in this variable. The value contained in a address is the memory address of A. This says, follow that memory address and give me the value you find there, which is a 5. So there's this is the address of A. We see it repeated multiple times up there. But then here is the value. This is star A address. The value that lives at A address, which is the same thing as the value of A. If I go back in here and I say \n A equals %d, and we throw A on the end of it. So star A address is the same thing as A. Make some sense? All right, so it's that syntax. That star of an address says, give me the value that lives at that address. The ampersand of a variable says, tell me where this variable is stored in memory. Not the value that lives inside of it, but the variable itself. Give me the address of this variable. All right, does that make some reasonable sense? Okay, then we should be able to apply that same thing to other examples like passing things to functions. So if we'll write it above, so I don't have to, well, whatever. We'll do the prototyping review here thing too then. So I'll say void change int A is equal to 13. So I'll do a printf in change int A is equal to %d A. Then we'll change it, print it out again. So let's go ahead and we'll say in main, A is equal to that. And then we'll call change int, passing it A. We'll call this again. I'll go ahead and prototype this up top so it doesn't scream at me. All right, so we have all this crap above that we already did. Now we're going to go ahead and we're going to print out the value of A in main, which is going to be a 5. Then we'll call change int, our function down here, passing in that 5. We'll print out the value of A again. Gonna still be a 5. We'll change it to a 13. Now it's a 13. Print it out again. Now it's a 13. Then this function ends. What's going to print right here? What would the output of this program be? What would the last line of this be is the real question here. 5? Okay. So there's our 5. How can I make it so that that last line is 13?
Pass by reference.
Okay, pass by reference. How do I force a pass by reference?
Couldn't you just add the ampersand to that
Well,
A?
let's start here. How do I make this guy? Here, we'll write a second version of this function. Change int by ref. We got to do both sides. How do I change this guy's expectation to expect the reference to an int?
You would
Would
have
this
to
be-
the
Go ahead.
add
That
the
guy?
word.
Okay, so now change int by reference is expecting an integer pointer. So now if I say change int by ref, I can't just pass in A, I have to pass in the address of A. Or I can pass in A address, one of my other variables up there that means the same thing. All right, but now when I come in here and I'm printing out a integer, is this a correct line of code anymore? If my intent is for it to print out the 5, what's wrong with that?
It's going to print out the memory address that the 5 lives at.
Well, it's probably going to give me a warning, I'm thinking, because I'm saying, hey, look, I'm going to give you a decimal. And
Yeah, sorry.
here's the decimal right here. It's an A. A is a variable, and that variable holds a memory address. That's not going to be compatible with this %d. It's looking for, it would be compatible with %p for a pointer. Okay. So how do I fix this line so that it will give me that 5?
Is it A% or A asterisk?
Like that?
Isn't that resolving the memory address to a value?
Put the asterisk before.
Oh, okay.
Say this is the value of A. The value of A, whatever A's memory address is, give me the value that you found there. And that's what I want you to replace this decimal holder for. Then how do we change? Because if I say A equals 13 here, I'm overwriting A with memory, like a forced memory address 13, which would probably scream at me because it's not, it would probably want me to do something like 0x, blah, 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 something like that. So this would probably scream at me, but I actually want to set the value that lives at the address of A equal to 13. How do I do that? How do I actually change the value at the address A? Yep. Star A equals 13. So see how it works on both sides? Okay, so star A equals 13. Then we'll print out again, same thing as before. That dude. This function then ends. We come back up here. We print out A, which should now be a 13 because we changed it. We passed it by reference and changed it at its actual place in memory. So there's our 13. All right, now what we just saw there is something that a language like Java does not let us do, because we don't get to choose how primitives are passed in Java. In C and C++, we do. But that comes with the caveat of now there's this creepy syntax that we have to deal with. All right, and whether we're dealing with primitive types or we're dealing with structs, we can pass structs by address as well, which we see plenty of examples of that in the code that we've looked up at this point, where we pass it a struct and that might get changed, so we pass it the address of the struct, and what it's expecting is a struct pointer. We make any changes to it, now those are permanent changes. So this is an example of how do we take something that's traditionally passed by value and force it to be passed by reference? But once we have it passed by reference, now we have the responsibility of dereferencing the values when we need the value that lives at that address rather than the address itself. All right, anything else you want me to look at with pointers?
So, again, I guess any specific files within the GitHub that relate to this.
Yeah, I mean, so, well, here, let's just open up. You could, I mean, everything kind of built and everything else, so you can probably do it. Maybe you look at proc with write. Let's just peek. So, I mean, yeah, this has plenty of examples of this. This is taking in a, even though I don't like the way this is written, I would write this as file pointer file. I hate when they put the spaces in there, but you know, same thing. Whenever you have, if this thing is taking in a pointer or taking in a pointer or taking in a pointer, like here, times when we change those things in here, we'll have permanent changes based on whoever called this. We should have, actually, this is a struct. Naming convention wise, usually when you have something that has an underscore, actually, I'm about to lie to you. Something that has an underscore T is usually a type, so it's usually a synonym for an existing primitive type. So it might be a float, might be a double, might be an int, something like that. Let me see if I can, well, yeah, here's our file. Our file here is a struct. So instead of it being an object, like we might think of a file object in Java, C doesn't have objects. So the way that they keep track of the information related to a file is by struct. And we're passing in a pointer to this struct here, as opposed to the struct itself. That way, inside here, do we do something with file? I don't actually see us doing anything. We don't even use it. So this actually is just the myRead function has to follow a criteria, is like an interface from Java. So it has to be a method that's written this way or a function that's written this way, and it's going to take in a file pointer, even though we're not using it here, it looks like. But be able to read code like this and tell me what that code is doing. Less important than writing that code on the first exam here. Yeah, so I guess in general, if you were gonna kind of study the code stuff, I don't know that it really matters which of the directories you look at. You should be able to look at something like this and walk through it line by line and kind of tell me what's going on. So this is kind of our example of how do we copy between kernel space and user space using our super duper magic function here, copy from user. You know, that's the powerhouse there, right? And we didn't write it. They provided that to us through UAccess and said, hey, you want to cross the boundary, use this special function and it'll make it happen. All right. Anything else you want me to look at? So I'll go ahead and push that so you have that new example. Okay, so what we're going to start doing is we're going to start writing a lot more code ourselves rather than looking at examples, because we want to start getting into inter-process communication and using inter-process communication to accomplish different things. We've already been looking at some examples of inter-process communication. But what I want to do here is we looked at an example of file locking. That's okay. And we're going to be implementing file locking. But before we do that, we want to do some file IO stuff. All right. So let's just get some simple code working for reading in from a file and then maybe writing out to a file. It's kind of a starting point. And then we'll do then what we write out to the file might be something a little bit different. What we're going to ultimately do is we're going to be sending secret messages using some inter-process communication. Okay, so did I mention at the end of the last class, I say that we were going to look at ROT13? Okay, and I asked, does anybody know what ROT13 is? I've introduced in other classes before. Do you know what I'm talking about when I say ROT13? Let's go right here. So that guy right there, ROT13, we've seen it before. You maybe heard me, but we've forgotten what it is, or have you never heard it? Okay, well, let me do it. Sometimes it's called the Caesar cipher. I think that's how you spell Caesar in this. Like Julius Caesar, is that how you spell Julius Caesar? Yeah, so it's called the Caesar cipher. When I call it Caesar cipher, does anybody know what it is?
Isn't it like an encryption algorithm?
Okay, yep, so this is an encryption algorithm. And how does it work?
This one where like visually it's like a wheel and then spin to like have letters meant it's like a shift cycle.
Yeah, it is a shift cipher. It's probably the easiest shift cipher. So this guy assumes an alphabet of 26 characters. How many characters were in the Greek alphabet? Alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu, nu, z, omicron, pi, rho, sigma, tau, upsilon, phi, chi, psi, omega. 24. So this one, ROT13, assumes, dude. Just imagine the number of things I've forgotten over the years. I think it was 24. Did I count right? But whatever. So we call it ROT13. Caesar cipher would have been actually, it would have been ROT. What I have 24? ROT12. So the ROT13 says we're going to rotate around the alphabet. So you mentioned it's kind of like a wheel where if we have our alphabet here, enter. All right, so that's our alphabet. And I want to take the letter C and I want to encode it using ROT13. I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's a P. C becomes a P. Now, what if I had a T and I want to encode it using ROT13? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Becomes a G. Okay, so it wraps around. That's the wheel thing that Brocker was talking about. All right, so what's nice about ROT13? Because how do we decrypt this? We decrypt this by saying, well, if I have a G and it's encrypted, I subtract 13, right? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's my T again. All right. What's a feature of the Caesar cipher that seems to be convenient for us? You notice the pattern yet? I know it'll work for ROT12 as well if we're dealing with the Greek alphabet. What alphabet did the Romans use? Was it the Greek alphabet? Or was it actually it probably was the Latin alphabet, which would be the basis for our alphabet. I wonder what's 26 characters. Doesn't matter, works either way. Pick your number of characters and as long as it's an even number of characters, it'll work. So what pattern exists here that makes the ROT13 convenient? Not necessarily the most secure algorithm, but convenient. How do we encrypt? We add 13 and wrap. How do we decrypt? Couldn't we also add 13? So encryption and decryption is the same algorithm. Make sense? So we had our, let me just count again so I don't mess it up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So from G, it was 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Gets us to our T. So we could encrypt and decrypt by adding 13 with wraparound. Okay, so that is the ROT13 algorithm. So let's actually, before we do file IO stuff then, since we covered that side of it, let's do a new folder, ROT13 messenger. File. And actually, just so I have a quick starting point, I'm just gonna steal main from here. All right, so we're gonna go ahead and we wanna write a function called, really it's encode decode, right? So let's just call it encode. So this guy is going to return a char. It's gonna be called encode. It's gonna take a char as a parameter. And this guy's job will be to convert this to the ROT13. In fact, actually let's call it encode ROT13, just so we can stay specific here. And what we want this to do is we want it to encode this guy using the ROT13 alphabet. So how would we go about doing this? Start with this, so we'll just do a, make sure everything's getting passed right. My prototype. So I'll say char C is equal to an A. And then we'll say encode ROT13, passing it that C, and it should print out an A. Oh, actually, I'm already in that directory, right? So there's our A. So what we really want though is we want this guy to give us for an A 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We want it to give us the N. So given an A, how do we get an N? Based on what you know about computer programming and how characters are stored and all that jazz. Okay, so we could create a string, right? So we can do something like char pointer alphabet is equal to, am I gonna be able to cheat? Big money, woot. All right, so I have the thing that's our alphabet. So now what do you want to do? You want to go through and you want to find where the character C lives in there, the index of it. Okay. Do we want to write a function that does that? So maybe we say int index of char C in char pointer S. And this guy will go through S and find the, and actually, because of this, we also need to keep track of int S length. Alpha length was 26. We just happen to know that, okay? So we'll say int index is equal to index of C in alphabet that has alpha length. And then we'll print out index. And let me prototype this guy so I don't forget. All right, so we're going to have a loop that's going to go through for int I is equal to 0, I is less than S length, I plus plus, ninja. And each time through, we want to ask the question, am I looking at the character? So now how do I get the character at bucket I in S? What is S? Some more review what we were just talking about a little bit ago.
Is S just a string?
Okay, well, that's what S, in practical terms, yes, S is a string. But S is a char pointer here. What's a char pointer? So what value does S hold?
An array of characters?
What value does S actually hold? Memory address.
Yeah.
Holds a memory address, which points to an array of characters, which can be thought of as a string, right? So all those things are true, but we want to make sure we're dealing with the actual, the skeleton of what we're dealing with here. Okay, that becomes more and more important with C, especially when we start writing it ourselves, right? It's been relatively easy. Let's say I know the things look a little cryptic, but when you see somebody else's solution and you read through, it's like, oh, okay, I kind of get what they're doing here and stuff like that. When they got 6, 7, 8 stars in front of stuff, you're like, it probably just works. It's fine. All right, but oh, and by the way, since we did cover it, now it's fair game on the exam for the entire Greek alphabet. I think she knows it. Do you know the whole thing?
No.
I'm going to randomly put it on there and see if people flip out. Should have been like, was it the movie Old School when Will Ferrell says, "What happened? I blacked out." When he did you see the movie? Oh, he gave this big debate. It was like went into savant mode and and he didn't even know what he was saying. In the end, he's like, "What happened? I blacked out. Did we win?" All right. Well, you know Omega. Yeah, well, now I am the alpha and the omega. Christian worldview. Point. Ninja. Whoa. Did people online hear the beep?
Yeah.
That was such great timing of it. I'm still right, just trust me. All right, so this guy has a memory address, right? I want to ask, is the character I'm currently looking at C equal to the character that lives at bucket I in this memory address? How would the cool kids write this? What do you want me to say? Star S? Just like that? What is star S? Okay, and what value in the string is that guy? Well, star S, if this is a string and S holds a memory address, what does that memory address represent? So I'm passing it in, I'm passing in my alphabet here, right? That's my char pointer. But what is the variable alphabet? It holds a very specific memory address. What does that memory address actually represent in this string?
Isn't it the first like instance of the array or the first memory address for the first element?
It's the base address of the array. So it's going to be the position where A lives. So now I'm saying over and over again, is this guy an A? 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 I want to say, is this guy equal to the character that lives at bucket I? How do I say that? Bucket I here is representative of our offset. So if my base address is S, and I want to take I number of steps away from S, and then I want to get the value that lives there. That will be a character. So for instance, if this is the base address and I want bucket 4, 1, 2, 3, 4. This is the value that lives 4 char size steps away from the base address in alphabet. So this says if C is equal to the character found at bucket I in S, that is the value that I found at this memory address plus this number, where that number is the number of this guy's type steps, char pointer, or really it's char size steps. Char pointer points to the beginning of it, the base address, and then we take char size steps to walk through memory. Okay. So this would be considered pointer math. Here's the base address. I'm adding to it a new number. And that number represents the number of steps to take. It represents an offset. That is the number of steps to take from the base address. How big is each step? Depends on the kind of value that's held at each of those addresses. So if the character that I'm looking for was found, this basically says if it was found at bucket I, right? I'm returning the index, so I'm going to return I. Return -1. Otherwise, that's how index of is historically worked, right? Zip through everything. If I found it, great. If I don't find it, return -1, not found. So now we'll go ahead and what am I passing in here? I'm passing in an A. It should find an A at bucket 0. So let's see if that's true. Kind of a boring first test. There's our 0. Let's now change this to like a T. $19. Change this to a question mark. Not found. We've tested it exhaustively. It works perfectly. Okay. It usually works, doesn't it? It's exactly, Mr. Gonzalez tests that way, but he doesn't even run the first test. Doesn't even compile. He submits. And trust me, some of the 200 and 250 assignments look just like that. It's like, I just uploaded this. Like, this is your math homework, and it's more correct than it probably would have been otherwise. All right. So we have our encode ROT13. We know how to find an index now. Okay, so now I have the index. What do I want to do with that index? You were telling me we're walking the string. I now know where it is in the string. So how do I encode it? Okay, so I want to add 13 to the index, right? All right, so I'm going to say index is equal to index plus 13. All right. So I got that. But now what if it's greater than 26? How do I handle that? Well, index is going to be a new value, right? So let's just say it's a 28. Just one off the end of it. What I then want to get is a 2. Because after we hit bucket 25, let's say we then go to bucket 0, bucket 1, bucket 2. Okay, so I would want to get a 2 from it. So how do I turn index of our example 28 into a 2? Well, let's not be too, ultimately we're going to do this. Yeah, we're going about this. We're taking the scenic route, right? Right now, solving the problem. But that's okay, because remember, it's always, let's solve in the way that makes sense to us first. Then we'll do our little math tricks. All right. So if I have a 28 here, and I know I have 26 characters, how do I use a 28 and a 26 to get a 2? Subtract, right? 28 minus 26 gets me a 2. All right, so we'll say int diff is equal to alpha length minus index. Now, what if index had been something bigger or something less than? Well, let's say it was at a 21. Instead of 28, it was a 21. So now I have 26 minus, actually, hold on, I did this. Let me write this the way I said it. Are we on time? Oh, last minute. That's okay. We'll leave this at a good point. All right, so now I have my 28 minus my 26. That gives me a 2. Now we have a 21, let's say, in another example, minus a 26 is going to give me a -5. So if it gives me something that's less than 0, I know I didn't go off the end of it. But it gives me something that's more than 0, that means that I am wrapping around, right? So we'll say, how did we tell if we wrapped around? Start here like that. All right, so on Wednesday, the exam will be open. It'll probably be open before class starts. But you can expect to spend class time doing the exam. I will be live at a computer if you have any questions. I'll actually probably be sitting in my office. So do the exam during class time. I will have it graded before class on Friday because I'm going to turn the grades in for midterm Friday night. So make sure if you have any questions on the grading or whatever, you let me know. Questions, comments, concerns, bribes. I'll see everybody on Friday, but I'll be in some touch with you on Wednesday at some weird level. But we won't have class Wednesday because you're taking your test during class time. All right, have a good one.
I have a question about something not related, actually acronyms that I couldn't figure out through Google.
Okay.